All right, guys. So in the previous video, we explained implicit functions involving exponential function, and of course, we're actually having a mixture here of both exponential function and then a trigonometric function. Both are all implicit functions since I have x and y cohabiting with one another. So we still have to employ the rules to differentiate these functions implicitly. Okay. First off, I always say if you're differentiating an implicit function, consider both x and y to be a function of x, and then you differentiate them as well with respect to x. So which means I'm going to differentiate the whole of this function. Okay, 3 is a constant, pull it out. So I'll simply find d dx of this exponential function, exponential xy squared. Okay, plus I will also find d dx of this trigonometric function cos xy. I will also find, okay, 5 is a constant, pull it out, d dx of this other trig function sine x squared y. Okay, so basically it's still the same thing as normal differentiation, only that this is an implicit function and then we have to pay attention to all our rules when differentiating implicitly. And please do well to look up my shortcut approach on how to differentiate a trigonometric function from shortcut. I did that on my video. I think I'm going to drop the link. I'll drop the links in the description below, both for exponential functions and of course for trigonometric functions, so you can actually grasp them properly. So do well to look up the description to get the links on how to differentiate a trigonometric function by shortcut. But we're going to still review the shortcuts over as we go through the question. Okay. Now, it has already been explained to differentiate an exponential function. I did that in the previous video. This is simply 3. So I'll open a bracket. The rule simply says differentiate the power of the exponential function. Use that derivative to multiply the exponential function. That gives you the differentiation itself. So I have the power here to be xy squared. Since they are multiple of each other, they are multiplying each other, it means I'm simply going to employ what? The product rule of differentiation. And from product rule, simply you keep x constant, differentiate y squared with respect to x. So you're differentiating y squared plus, now you keep y squared constant, you differentiate x dx with respect to x. Okay, whatever you obtain from this derivative, multiply it by the exponential function itself, xy squared. That gives you the whole derivative. It's as simple as this. Okay, plus now I have cos xy and I'm asked to differentiate this. This is an implicit differentiation, and to differentiate a trigonometric function from shortcuts, I made a video on that. Please do well to look it up. But to do this, first of all, you differentiate the angle in front of the trig function. Use that derivative to multiply the derivative of the trig function itself. It gives you the answer. The angle in front of this trig function cos is simply x and y. So I will simply what? Differentiate xy, use the value to what? Multiply the derivative of the trig function cos. If I differentiate cos, I will simply have minus sine. Okay, so first of all, let's start by differentiating the angle in front. The angle is simply xy. Since they are product of two functions, x multiplying by y, you also employ product rule to differentiate that angle. First of all, you keep x as a constant, then you differentiate y with respect to x. Then you keep y as a constant plus y. Now you differentiate x with respect to x. So I will have dx all over dx. Having done this, you now differentiate what? The trig function itself. If I differentiate cos, I will simply have minus sine. So multiply by the derivative of the trig function minus sine xy. This becomes the differentiation of this whole function. The same rule apply for sine. So this is now equal to okay, so this is now equal to, you keep 5 is a constant, put it out. The same rule applies. You differentiate the angle in front of this trig function, and the angle in front of it here, please pay attention here now. This is actually x squared y. So simply, since they are multiplying each other, you still employ the product rule. Okay, but now pay attention to the power on x. Okay, so from the rule, keep x squared constant, differentiate y. I will simply have x squared hold constant, then differentiate y with respect to x. plus, now you keep y and differentiate x squared with respect to x. So plus y differentiate x squared, okay, with respect to x. So that's d of x squared all over the x. Okay, and you use this derivative now to multiply the derivative of the trig function itself. If I differentiate sine, I will simply have cos. So simply attach cos x squared y. So this becomes the derivative of what? That given function. Okay, so let's start by evaluating the exponential function. This is now 3 into, of course, if I differentiate y squared, I will simply have use the power to multiply y. So this becomes x times 2y, then subtract 1 from the power. 2 minus 1 is 1, so you simply you're left with 2y. And since I differentiated y with respect to x, you simply attach the y all over the x. Okay, plus this is now y squared. Of course, the x over the x is 1, so it's off. I have this multiplied by the exponential function x y all squared plus, okay, this becomes x dy all over the x. Of course, y is not raised to any power here, so it remains the y over the x. Plus here I have the x over the x, that's 1, is off. So simply plus y multiplied by minus sine x y, and this is equal to, I have here now 5 into, this remains x squared dy all over the x. Of course, y is also not raised to any power, so it remains dy over the x. Here now, I'm to differentiate x squared, and of course, use the power now to multiply x, then subtract 1 from the power. I'll simply have plus y into, this becomes 2x. If I differentiate x squared, I will simply have 2x. Now, since I differentiated x, I would simply attach what? The x all over the x multiplied by cos s squared y. So I'll simply have this. Okay, this is now 3 into, this becomes 2xy dy dx, okay, plus y squared all into exponential x y squared, okay, plus okay, I can decide to evaluate this at once. Okay, I think I should evaluate this as at once. So I have here x dy dx multiplied by minus sine xy. That will give me minus x sine xy dy all over the x. Y multiplies minus sine xy simply gives me minus y sine xy, and that's equal to, same thing applicable here. I have 5 multiplied by x squared dy dx, also multiplied by cos x squared y. That gives me 5x squared cos x squared y multiplies dy all over the x. Of course, if I evaluate this, I'll have 2xy multiplied by 5, that's 10, multiplied by cos x squared y. I will simply have plus 10xy multiplied by cos s squared y, and over here, of course, the x over the x is 1, so that's also, we simply have this whole thing to evaluate. So I think I should wipe this top because this equation is very long. I can't do that over here, so I'm going to wipe this top now and then continue. Okay, so if I expand this bracket as well, I will have there 3 multiplied by 2 here gives me 6xy multiplied by exponential xy squared, exponential xy squared dy all over the x, plus 3 multiplied by y squared multiplied exponential xy squared, that's plus 3 y squared exponential x y squared, okay, minus x sine xy dy dx, okay, minus y sine xy, okay, and that's equal to 5x squared cos x squared y dy dx, okay, plus 10xy cos x squared y, okay. So at this point, what I will do is simply bring all the terms, bring the y, the x's terms together and send the other terms over to this side of the equation. I think I have the y, the x here, so I can bring this over here, bring all the y, the x terms together. So from here, I have 6xy exponential x y squared dy all over the x. Okay, I also have here minus x sine x y dy dx. Okay, I also have here 5x squared cos x squared y dy dx. If I pull it over here, it becomes minus 5x squared cos x squared y dy all over the x, and this is equal to, okay, you keep this variable down here, 10xy cos x squared y, send every other term here which does not contain the y, the x over there, so plus 3y squared exponential xy squared, positive sign cross and equal to sign becomes negative, so I have minus 10, I have minus 3 y squared exponential x y squared, okay, negative y sine xy cross over here becomes positive, so plus y sine x y. So I'll simply have this. So at this point is to simply factor out, of course, the y dx is common amongst all. You simply factor out the y dx. I will have 6xy exponential x y squared minus x sine xy minus 5x squared cos x squared y all multiplied by the y all over the x, and the whole of this is equal to, I have here 10xy cos x squared y minus 3y squared exponential xy squared plus y sine xy. So I'll simply have this. So it's easier now. We can make the y dx subject simply by dividing the whole of this variable by the whole of this variable. This now implies that the y all over the x is now equal to the whole of this 10xy cos x squared y, okay, minus 3y squared exponential x minus 3y squared exponential x y squared plus y sine xy, okay, plus y sine xy all over, okay, the whole of this variable. We have here 6xy, 6xy exponential x y squared minus x sine xy minus 5x squared cos x squared y. All right, so that becomes the final answer to that derivative. So once again, the basic rule of differentiating trigonometric functions from shortcuts, I've done that. You can look it up. I'll post the links once again in the description below, so you may do well to check it up for proper understanding. But then that's how to differentiate implicit function when it has to do with trigonometric functions. And in this case, we also considered both ways, trig and exponential functions together. All right, I will see you in the next video. Thanks and cheers.